All right, grade 12s, welcome. We're up. In this explainer, we are going to lock in those key definitions to get you absolutely exam ready. So here's how this is going to work. It's super simple. I'm going to show you a term, and I want you to actually pause and say the definition out loud, like for real. Then I'll pop up the official answer. This is called active recall, and trust me, it's the best way to make these things stick in your brain. Ready to go? Let's dive in. First up, we're tackling the heart of electrochemistry. You know, these terms, they're guaranteed marks if you know them cold. So seriously, don't just listen, say the answers out loud. Let's see how you do. First term is on its way. All right, first up, a big one. What is a galvanic cell? Think about the main energy conversion that's happening here. Go on, pause, say your answer out loud. Let's see if you've got it. Okay, so the key thing here is it's a cell where chemical energy gets converted into electrical energy. The easiest way to remember this, just think of a normal battery, like the one in your TV remote. It's a spontaneous reaction that just happens, and it gives you power. Now, what about the opposite of this? So, what about an electrolytic cell? How does this one differ? We know it's the reverse of a galvanic cell, right? So, what does that mean for the energy conversion? Take a second, pause, and define it. You got it? Okay, let's check. Exactly. So a galvanic cell is spontaneous, right? It's your battery powering something. But an electrolytic cell is non-spontaneous. Think about recharging that battery. You have to plug it into the wall and force electricity in to make the chemical reaction happen. Makes sense, right? Okay, next pair, oxidation versus reduction. I want the definitions in terms of electron transfer. Come on, this is a classic. You have got to know this one. Go for it. And the way to remember this forever is O-L-I-R-I-G. Oxidation is loss, reduction is gain. Say it with me, O-L-I-R-G. Seriously, burn that into your brain. It will absolutely save you in the exam. Okay, same concept, but now let's define them using oxidation numbers. It's a different way to look at the exact same thing. So what happens to the number in each case? Just think about it. What happens to your charge when you lose or gain negative electrons? Well, if you lose negative electrons, your oxidation number has to go up, right? You're becoming more positive. And if you gain those negative electrons, your oxidation number goes down. It's pure logic. Now, every one of these reactions has two key players, the agents of change. Now, what are oxidizing and reducing agents? Okay, be careful here. This is where so many students get mixed up. An agent is something that causes something to happen. So think about what each agent does to the other substance. What's the definition? So here's the trick. The oxidizing agent is the substance that causes oxidation, which means it gets reduced itself. And the reducing agent is the substance that causes reduction, which means it gets oxidized. It's all about what it does to the other guy. It's the agent of change. Okay, next pair, anode versus cathode. Where do oxidation and reduction actually happen? This is a quick-fire round. Which process goes with which electrode? Go. And we've got another fantastic mnemonic for this one. Anox, anode, oxidation. And red cat, reduction, cathode. See how that works? Anox, red cat. Easy way to remember it. The vowels A and O go together, and the consonants R and C go together. Simple as that. All right, next up, what is an electrolyte? Think about the solution inside the cell. What allows it to conduct electricity and complete the whole circuit? Quick hint, it's not electrons moving through the solution. So what is it? What's the definition? There it is. The key word is ions. You've got to have those mobile ions moving around. They're the charge carriers in the solution that let the circuit be completed. Awesome. Okay, final term for this round, the name of the process itself. Let's put it all together now. We talked about the electrolytic cell, right? So what do we call the actual chemical process that's happening inside it? Excellent. And that wraps up round one. You've just nailed the electrochemistry basics. Nicely done. Okay, take a quick breath, because now we're going to switch gears. Let's move from the reactions themselves to how we actually investigate them. All right, round two, investigation skills. Now, these definitions are so important for any question about experiments. Honestly, these are easy marks just waiting for you, so let's lock them in. First up, let's talk variables. Okay, so every experiment has three key variables. What are they? The dependent, the independent, and the control. Let's break them down. First, the independent variable. What's that? Pause and think. It's the one that I, the investigator, choose to change. Now, what's the dependent variable? That's the one you measure to see the result of your change. It depends on the independent variable. And finally, the control variable. That's everything else you have to keep exactly the same to make sure it's a fair test. You've got to know the difference between these three.
And to wrap this section up, let's hit 3 key concepts for setting up any good experiment. First off, what's an investigative question? It's pretty simple, right? It's the question you're trying to answer. Next, what's a hypothesis? That's your prediction, your educated guess about what's going to happen, written as a statement. And finally, what makes something a fair test? What's the golden rule? You can only change one independent variable at a time. That's it. Get those locked in your head.
And that is a wrap. Quiz complete. So how did you do? If you nailed all of those, wow, you're in a fantastic position. If you stumbled on a few, hey, that's totally fine. That's exactly why we do this revision. Just watch this explainer again tomorrow and see if you can get them all. Repetition is key. Hey, if you found this helpful, could you do me a huge favor and share it with a classmate? Let's get everybody ready for these exams. And for more daily revision questions and tips, you know the drill. Like, subscribe, and stay sharp. And one last thing before you go, drop a comment below and let me know what topic you want me to quiz you on next. Should we do organic reactions, acids and bases? You tell me. Keep up the amazing work, guys. I'll see you in the next explainer.